Okay, let's look at the problem. We're asked to calculate the pH of 1 molar methylamine. We're given a Kb value. So we're given the Kb because methylamine will act as a base. We need to fill out our ice table. We're going to start with our methylamine and we're going to react it with water. So remember, we have this nice lone pair on the nitrogen, which will attack one of the hydrogens. And that's how we get the extra hydrogen here, and it's a positive charge. It's in water. And then because the water has lost one of its hydrogen ions, we end up with hydroxide. So it's very important that we get our equilibrium reaction correct. Just take your base and add it with water. So always base plus water, and then do your reaction. So our initial is 1 molar, 0, 0. Our change is minus x plus x plus x. So the equilibrium is 1 minus x, x, and x. So now we just have to set up our expression, and because this is a base, we are going to use the Kb. So it's really important that you label this as the Kb, put in the value for the Kb, and then our products. So here's our product, goes here. Here's our hydroxide product that goes here. Products over reactant. Here's our methylamine that goes here. And then remember, water is a liquid, and liquids do not show up in the expression. So then we put in our x, our 1 minus x, and then we will assume this x is small. So that will simplify the equation. And then we will get this. I don't know what the heck happened. Let me fix that. That was minus 4. Maybe type in. So when we solve for the x, we get a value, and then remember that the ice table tells us what the x means. So in our column under hydroxide, we had x. That means that our x is equal to our concentration of hydroxide. We can then use pH equals minus a log of POH concentration. POH equals minus the log of hydroxide concentration. So we put the hydroxide concentration in here. And we get for the POH 1.679. Then we need to use the next equation. The next equation is that your pH plus POH equals 14. So we have the POH. We put that number in. That was here. And we can solve for pH. So we get our pH value. So you're going to want to practice these problems so that you become more comfortable with them. But remember, if you have a base, add water. Okay, so what we're going to do is look at the relationship between Ka and Kb. So we are given that Ka times Kb equals Kw. And we know that the Kw is 1.0 times 10 to the minus 14. So let's say we're given a problem and the problem gives us a Kb and asks for the Ka. So we would put the Kb, which we were given, into our equation of Ka times Kb equals Kw, and then we can solve for the Ka. So let's say we're given another problem. The problem is asking for the Kb for cyanide ion. It's giving us the Ka for hydrocyanic acid. So if you recall that hydrocyanic acid is not on our list of strong acids, so therefore it must be a weak acid. It's in equilibrium with hydrogen ion and cyanide. So this is our acid, and this is the conjugate base. So we were given the Ka for the weak acid, and we need to solve for the Kb for the conjugate base. So we use our formula, Ka times Kb equals Kw, and then we can solve for the Kb. So the next problem gives you the Ka for ammonium ion, or asks for the Ka for ammonium ion, and gives you the Kb for ammonia. So again, you use Ka times Kb equals Kw, and you solve for the Ka.